So today we're going to talk about a mid-segment theorem for a triangle. Does anybody think they know what mid-segment might mean? What does mid mean?
Middle.
Middle. And a segment is a part of a line, right? So really what we're doing here is we're drawing mid-segments of a triangle. It's a segment that connects the midpoints of two of the sides of the triangle. So if you notice right here, when you draw this mid-segment from this side to that side, we broke this into two equal pieces, and we broke this side into two equal pieces because mid means middle. It went through the middle of the two sides. Does that make sense to everybody what the mid-segment's going to do? Okay, when that mid-segment is drawn, it does something even more special to this triangle. When you draw this mid-segment from this side to that side, this mid-segment becomes parallel to the third side of the triangle that it's not touching. Okay? Do you guys remember that those little arrows mean parallel? Then the other thing neat that happens is that we have a relationship between the length of this mid-segment and the length of the third side. Does anybody think they might be able to guess what the relationship is between this piece and that piece?
They're both parallel.
Okay, they are for sure parallel. So I'm gonna write that down so that you don't forget that. So DE is parallel to AC. That will happen when you draw your mid-segment. Okay. Now, how do you think DE compares to AC? Do you think they're the same size? No? So they're not the same size, but AC is twice as big as DE. So if I do 2 times DE, it would be equal to AC. Does that make sense? That if I took the little one and I times it by 2, I would get the length of the big one. Okay? So that's what a mid-segment does. That's a hard word to say for some reason for me. It takes it divides the two sides of the triangle into two equal pieces and is parallel to the third side and is half the size of the third side. So you could write it this way, 2 times DE equals AC, or you could write it as 1/2 of AC equals DE, right? Those two rules mean the same thing. You could write it either direction, okay? So what we're going to do today is we're going to use this rule of a mid-segment to just solve for the missing variable in some problems. So let's look at this first one right here. Oh, stop. That was close, huh? I know, no. This Zoom doesn't like me.
Yeah, Zoom's a pretty bad villain.
It is to me. That's good enough. There we go. Okay. So it says solve for x and then find the length of AB. So we're looking for this length right here after we solve for x. So if I know that this piece right here is 3x minus 1, and I know that this piece right here is 34, do I know what this length has to be equal to? Is it 34 or is it would have to be half of the 34, wouldn't it? Because do you remember how I said up here that one of them is twice as big as the other, which means the other one is half as big as this one? So if this length is 34, what's this length going to be? 17. So using that 17, could I solve for x? I totally can. I can go 3x minus 1 equals 17. And then I'm just going to solve that from there. So what's my first step? Plus 1. And I get 3x equals 18. Next step?
Divide 3.
Perfect. And what's my x value? 6. Okay, now I can check my work here. I already found the length of AB, which is what the instructions asked me to do, but let's just sub that in to make sure it works. 3 times 6 is 18. 18 minus 1 is 17. So I did my work correctly. So again, when you draw the mid-segment, it is half the size of that side that it's parallel to. Does that make sense to everybody, the rule? Okay, so let's look at this next one. This one says solve for x and solve for y. So we're going to have to do two separate problems on this one, but we totally got it. So let's just talk about, can we do the y's first? Is that okay? What do we know about these two pieces of this side of the triangle? Do you remember what this mid segment does? Yeah, it finds the middle of that line, right? So this side has to be equal to this side because that's what the mid segment does. So I can write my equation and say that 4y equals 6 times y minus 1. And I can just solve that equation for y. So what's my first step here? What do I need to do? Distribute, good. So I have 4y equals 6y because of the 6 times the y. And then I have to do the 6 times the negative 1, which is a negative 6. Okay, my goal is always to get my y's on one side together. Always isolate the variable. So I'm going to subtract my 6 y's over to this side to get the y's all together on one side. So when I subtract my 6 y's over, how many do I have all together? Good, negative 2y. And it's equal still to negative 6. Last step on this one. Perfect. Divide by negative 2. And y equals, perfect, 3. So my y value is 3. Now I have to find my x value. So I know the relationship between this mid segment and this side of the triangle. What do I know about this one compared to that one? This one is 2 times as big as the other one, right? So if I take this one and I times it by 2, wouldn't it be equal to that one? Do you guys agree with me on that? So that's the way I'm going to write my equation, okay? I'm going to say 2 times the little one equals the big one. Does that make sense how I set that up? Because I know that the mid segment is half the size of the side that it's parallel to. Now what am I going to do to solve this one? I'm going to distribute first. Good. So what do I get when I do that? Yep. Perfect. And then it's still equal to 4x minus 2. Now, I like to isolate my variables, get them all on one side together. I don't care if you move the 2 this way or you move the 4 that way, whichever you prefer to do. I like to keep my variables positive. So I would want to move the 2 to this side. Is that okay if I do it that way? So the 2 is positive, so I'm going to subtract it to the other side. And I get 8 equals 2, perfect, 2x minus 2. Next step.
Add 2.
Yeah, add 2, good. Get the variable by itself, so I'm going to add the 2 to the other side. So I get 10 equals 2x. Divide by 2. And x equals 5. That was a little bit of work, you're right. Okay, questions on how I solved for the x value there. So again, the rule for mid-segment says that the mid-segment is half the size of the side that it's parallel to. Okay? All right, this one is easy, so let's think about this for just a minute. Okay? And this is going to be an extension of some rules that we already know. So, did we just say that these two lines right here would be parallel to each other? Yeah. And do you guys remember a rule that said something about a parallel line cut by a transversal? You guys remember those rules from before? Yeah. So a parallel line cut by a transversal, what kind of angles would these two be then? Ooh. They're inside the parallel lines.
There's
nothing in between them. So they're called
Consecutive.
Yeah.
Ah, got it.
They're consecutive interior angles. Does anybody remember what we know about consecutive interior angles?
They're Asian. So
Are they equal or do they add, there's two different options. They either have to be equal or add to 180, which is, yeah,
Yeah. And that word was supplementary, right?
yeah.
They add to 180. So if this is 30, what does x have to be?
So 180 minus 30 is?
There we go, 150, because they have to add up to 180 degrees. So they add up to 180. Did I say 150? I don't know.
Yeah.
They had to add up to 180, so this has to be 150. 150 plus 30 is 180. Okay.
that'd be fitting.
All right, this next one looks really kind of confusing, but we're really just going to look at it and fill in the blanks. So it says triangle ABC is similar to what triangle? So one squiggly line means similar. Similar means they have the same angle measures, but they have different lengths of sides. Okay? So ABC, so from here to here to here, is going to be similar to which one? Okay, that little triangle in the middle there, right? I 100% agree with you. So the only thing that we have to be careful with is that we have to list it in the same order as ABC. So A to B to C. So A is up above that right angle. B is over on the, like the hypotenuse, and C is the going back to the right angle here again. So if we're going to go in that direction on this triangle, which letter goes first? Because we went A to B, so down the hypotenuse, right? Then we did the long side, and then we did the short side. So we have to go hypotenuse, long side, short side. So what does that start with? What letter? There we go. So you do have to do it in the same order that the first triangle is written in. Does that make sense to everybody? All right, so this again, one squiggly means similar, means that they're the same shape but not the same size. Okay, two squigglies means congruent, so equal to. Okay, so this time we have angle SRQ. So from S to R to Q, this angle right here, I want to know which angle it's congruent to in the bigger triangle. It's angle A. I agree with you on that. Okay. And you could call it angle A, or if you wanted to call it by 3 letters, you could call it CAB, from C to A to B. Does that make sense how you could call it with 1 letter, or you could call it with 3 letters? It's up to you.
Cab.
Yeah, cab for sure. All right, last question on this note-taking guide. AC is parallel to what line? So AC is right here. What line is it parallel to? Yeah, SQ. Oh, S we said, and I'm writing an R. QS. You could write SQ if you wanted to. It doesn't matter. It's just that line segment there. I'm just going to write that again because that looks